All right, class, this is section 7.4, part 2, where we're going to be learning how to estimate a population variance. So we're estimating our standard deviation. Remember, there are a couple different measures of variation within a data set, and one of those is range, and the other one is standard deviation. So in this section, we're going to learn how to estimate our standard deviation, or standard deviation squared. We're going to determine the sample size we would need in order to estimate our population standard deviation, or standard deviation squared. So we've created some confidence intervals in previous sections for population proportions and population means. Now we're going to create them for population standard deviations. And to do so, we're going to need a new variable and a new table. So we have to make some assumptions, right? Whereas in the previous section, we assumed that all of our distributions were normal and our sample size was greater than 30. Here we have to assume that our sample is a simple random sample, that the population is normal. And this assumption is critical, okay? These are our two assumptions. Critical in order to be able to estimate our standard deviation, or standard deviation squared, which is the variance. So here's our new statistic. This is called a chi-square statistic. Here it is. So chi-squared is our sample size minus 1 times our sample standard deviation squared over our population standard deviation squared. And we're going to be talking more about how to use a chi-square statistic in later chapters as well. So I just wanted us to have a first chance to take a look at it towards the end of chapter 7. Okay. This chi-square is table A-4, okay? And just like with the T-table, we do have degrees of freedom, which we calculate the same way. And it's important to note that chi-square can never be negative, okay? Chi-squared is measuring the area to the right of a critical value, but it isn't in a normal distribution. It's a chi-squared distribution. So say we're going to set our alpha be 0.05, right? That means we're creating a confidence interval of what size? 0.95 or 95%. Okay? That means the area in each tail will be 0.05 over 2, which is 0.025. Okay? Note, say we have a sample size of 10, so our degree of freedom is 9, and we have to come up with two critical values. Okay? This table's unlike a z-table, which told us the area to the left. This tells us the area to the right of a given chi-square value. So now we're finding the area to the right. So if we go to table A4 and we go down where the degree of freedom is 9, okay, I want to go to the column where it says 0.025. If you go to the column where it says 0.025, you should see the number 19.023. Okay, and this is the area to the right of the chi-square value of 19.023 is 0.025 of area. Okay, this is the area to the right of this chi-square value. Okay, now we need to find another chi-squared value. We need to find the left-hand critical value. So we're going to be in the same row where the degrees of freedom is 9, but now we go to the column where it says 0.975, because 0.975, okay, is going to be the left-hand value, right? If we have this, we've got two tails. We had 0.025 over here. And if we want the 95% confidence interval, we add these together and know that this marks 0.9. This whole area over here would be 0.975. Okay? So if we go to 0.975, you're going to see a value of 2.7. And this has the area of 0.975 to the right. So it's actually over here. Okay. The best point estimate for our variance, for our standard deviation squared, is It's going to be our sample deviation squared. And the confidence interval estimate for our variance, our standard deviation squared, so variance, is going to be our sample size minus 1 times our sample deviation squared over our right chi-square value, and our sample size minus 1 times our sample standard deviation over our left chi-squared value. The best estimator for sigma is going to be to take the square root of those values, right? If we take the square root, we're undoing the square. So let's work out a problem. We want to find a confidence interval estimate for sigma, or sigma squared, based on this information. N is 20, so my degrees of freedom is going to be 19. We have a mean of 95,000, a standard deviation of 1, 2, 3, 4, 5, and I want a confidence interval, a 95% confidence interval. So I know the area is in two tails is going to be 0.05. So that means the area in one tail is going to be 0.025. So first, we compute n minus 1 times s squared. This is a really big number, which we then find our chi-squared value, which is 32.8.5, and our chi-left squared value, which is 8.907. You're going to do this by finding, because our degrees of freedom was, I forgot our degrees of freedom. Our degrees of freedom was 19, right? So I go to my chi-squared value, and I find that for a tail, an area of 0.025, right? Because I want my right value. This is 32.852. And the area for the left, this would match up with degrees of freedom 19 and our area 975. We have a chi-squared value of 8.907. Next, I'm going to substitute in my values, and I find that my confidence interval for sigma squared, so our standard deviation squared, which is the variance, is these two big numbers right here. And to find the confidence interval for our standard deviation, we are going to take the square root of each of these above, and we get 9,388 to 18,030.